Okay, still working with the flyback. Just to remind you, flyback converter is book boost converter, but we just improve it by adding here high frequency transformer for isolation. And we solved last session in tutorial 2 problems. Today we'll continue with another 2 problems. Have a look here. Okay, let me read the question. A flyback converter, okay, to produce output, this is V out, 32 volt, from an input VD, 24 volt. The load resistance, RO, 20 ohm. Designed for continuous current, continuous conduction mode, here's me, continuous conduction mode, and the transformer magnetizing inductance. The minimum current in the magnetizing inductance should be 20% of the average current, 0.2 of I average. Okay, the voltage ripple on the output must be less than 1%. Voltage ripple 1%, mean 0.01. Choose the transformer turn ratio, so you will assume it. As example here, I assume it N2 to N1 is 1 to 2. You can assume whatever the value you want. And magnetizing inductance, the switching frequency, the duty ratio of the switch, and the output capacitor. Assume that all components are ideal. Now have a look here. Now he just told me that this is your output, this is your input, and the load is 20. And just he put here 2 constraints, the ripple and the magnetizing inductance current should be 20% of the average current. That's all. Everything else we need to assume or start to calculate. Have a look. As I mentioned, transformer turn ratio, we assume it as he mentioned here. You can assume the transformer turn ratio. I have here the formula used to calculate output with respect to input in terms of turn ratio and D. Now turn ratio, I already assume it, 1 to 2. V out and VD, he gave me here their values. I just need to substitute and solve to get duty cycle. Duty cycle also done. Turn ratio also done. Okay. Now magnetizing inductance, switching frequency, currents, capacitor, voltage, output, also he want me to find them. Just to remind you, don't forget that the inductance current assumed to be straight line in this way, increase, decrease. Here is the maximum, I maximum. Here is I minimum, and here is delta I, the ripple, and here is I average. Okay, now average current can be calculated, okay, in this way. Have a look. We know that from the principles of book boost converter that I out to I, because of PD equal PO, and this means that ID VD equal IO VO, then IO over ID equal VD over VO. Okay, now I can let me say cross multiply, then it will be ID equal IO VO over VD, and IO here is VO over R, right? So I can write it VO over R. So it will be VO square. And ID is the total current, but I will multiply by D to brought inductance current. Why? Because the inductance current, the current flow through the inductance when T on occurred. In T off, it will not follow through the inductance, right? So in T on, so then this D to come here, I have this formula. Do I have VO? Yes, I have. Do I have VD? D is already calculated. R is already given in the question. I got average value. Where is the average value? This one. This one, the average value. He told me, as you can see here, 0.2 of the average value. He told me that IL minimum should be 0.2 the average value. So I multiply 0.2 by the average value I just calculated. I got minimum. Now have a look again here. Let me plot it here. This one is 1.07 amp. This one is the I average is just let me take it from the other. Okay, 5.33. 5.33. Okay, this is I minimum. Okay, now delta I will be 2 LM because you know here I average here equal IL minimum, this one, plus from here to here, which is delta I over 2. So I can rewrite it to find delta I. I have IL average, which is 5.33. I have IL minimum, which I just calculated. Then I got delta I. If I got delta I maximum, which is this one, is this part, which is delta I over 2 plus I average, as you can see here. Delta I over 2 plus I average. I added them, I got the current. Now for the frequency, he told me assume the frequency. I have to assume it. I will assume it 30. You want to assume it 20, go ahead. 10, go ahead. It's fine. Okay. So I assume it to be 30 kilohertz. Now next I will find the maximum current. Sorry, the inductance. You want me to find the inductance. I have formula for I maximum. Let me see what I have. I maximum, I have it already. Okay. Ratio, I have it. D, I have it. IO, V over RO, already calculated. Again, this one. TS is 1 over FS. I assume the FS here, as you can see. So what is left? VO also, I have it. What is left? LM. I need to do the math to get the inductance. I got it. Okay. Now finally is finding the capacitor. Okay. The capacitor value. Delta VO over VO equal DTS over RC. We have this formula from book boost converter. I have D, I have TS, I have R, and this ratio I have it 1%. Then what is left? C, I calculated. Now let me list what we calculated, what is needed to design the circuit. V output, V input, already given in the question. Frequency switching, I assume it, as you can see here, 30 kilohertz. Okay. Now, by the way, when you assume frequency as example, you build the calculation based on this frequency. Okay, because TS, it's lead to TS, and then you can find or calculate the values for your components based on this FS. FS also, I have it. The switch. Important to know its maximum current. It's good if you have minimum current, average current, all of them, I have them. Okay. I know delta I, the ripple in the circuit, because this is related to the filter later on. What else? Capacitor, I also calculated. I am given also RO. So already I have everything needed to build my converter. Another question. A flyback converter with 2 windings inductor consists of an ideal transformer and an ideal inductor, which equal the magnetizing inductance LM. The complete specification are given below. Have a look. V input, this is VD or V input, 300. V output is 6. Step down here. D is 0.4, he calculated for me. Output current is 30 amp. Frequency is given also. V out ripple, delta V, is given 100. Ripple in current, delta I, is given also peak to peak by here, peak to peak, from maximum to minimum. 4 volt voltage drop across rectifier diode. Oh, he gave me here drop across the diode, which is 1 volt. Draw the circuit. Okay, I can draw, it's easy. Calculate turn ratio. Just a minute. I have D, I have input, I have output, I have formula, right? I can substitute to find turn ratio. Let me take them one by one. Okay. Now the circuit is easy to plot. You see here, this is my transformer, and this is the switch, the diode, capacitor, and my load. For the turn ratio, I have this formula which say output equal input voltage turn ratio D over 1 minus D. D is given in the question. V input output is given in the question. Then I calculate turn ratio, which is found to be 33.3. Let me back to see here. These two parts already calculated, plotted and calculated. Okay. Calculate LM when delta I M equal maximum minus minimum is equal to 0.2. He told me now make it 0.2 amp. Okay. Delta I equal 0.2, which is equal to, from principles of buck-boost converter, VD DTS over LM. Let me see. VD, I have it. D is given in the question. TS 1 over Fs, which is given in the question. Okay. And this drop is 0.2. Also, he told me in the section. Then I can find the inductance. I got it. Just substitution, and then you got it. Okay. Calculate the maximum transistor current, switch maximum current, and sketch the switch current I switch. Okay. Now, I maximum, I have formula. You remember I have formula. We discussed this in the lecture session. Now, I have here, I wanted the switch current here. Okay, let me see. Turn ratio, I have them. Output current, I have it. D already given in the question. LM, I just calculated. Again, D, turn ratio. TS, I have the frequency. Output voltage is given the question. So I just need to substitute. By the way, N2 over N1, okay, N2 over N1. So N1 can be, just to simplify, N1 will be 3.323 by N2. So just to substitute, to simplify, so we can cancel them. We did the math, we calculate them, and the final current was 1.6. This is the maximum current. Now, let me back. I calculated part number 4. Calculate the, by the way, sketch the current. Where is it? This is the current, I switch current. Switch current, when the switch is on, we know this is the current. Okay. When the switch is off, zero current flow through it. Okay. If the inductance, you see, increase, decrease. But now we're not talking about the inductance, about the switch. Now, I calculated here the values, the maximum value, as you can see here, and the minimum value. I have it. Okay. So this is how I sketch it. It's not only sketch the waveform itself. No, you need to specify the current here, the T on. It's easy to specify, by the way. You know T on equal DTS. You already have D, you have TS, and T off is 1 minus DTS. Also, you have them. So just put the values. TS is the total, which is 1 over Fs. Okay. Calculate the voltage across the switch when it is off. Okay. Voltage across the switch when it is off. When it is off, the switch current, okay, during this time, on time. Okay. This is part related to the minimum, to find the minimum current. The minimum current will be I switch, the switch at 0, the initial, VTD, T over LM. We have all of them, so we got the current. But next is to find the switch voltage. Switch voltage, I switch, will be VD, which is given in the question, 1 minus D. This formula, you have it in the lecture session. So you just need to substitute to find the voltage. Now, next week I will give more, let me say, tutorial problems. We will discuss more. Okay, we are moving step by step as you know, we just finished the flyback. Next, we need to go for forward and other